Today we're going to begin our discussion of energy resources. Up to this point we've talked a lot about ecosystems. We specifically dove into human population, and we know with overpopulation that puts an absolute increase on Earth's resources. One of those that's really important are our energy resources. So today I want to kind of move us into that discussion, beginning our discussion with the most common energy resources are non-renewables. These non-renewables include our fossil fuels and nuclear power. When we look at our energy sources that we use today, at the top of our chart here we'll see the four non-renewables that we're going to talk about this week, including our three fossil fuels, our oil, our natural gas, and our coal. As well as nuclear power, so we'll focus our discussion on that first. And then we'll turn our discussion next week to talking about our renewable resources, and those are things like biomass energy, hydropower, solar, wind, geothermal energy, and tidal, or what we call wave energy. We'll also talk about hydrogen fuel cell technology as an alternative renewable source of energy. And that's kind of the last one that we'll discuss before the end of this topic. All right, when we think about renewable and non-renewable, we categorize them into these two different categories because of their kind of the amounts that we have on Earth, so to speak. So when we think about our non-renewables, like our fossil fuels, we know that there's a finite amount pretty much here on Earth. They are reproduced slowly in the earth, but it takes hundreds, thousands, or millions of years for them to form. Nuclear power is derived currently from uranium, and we'll talk about the fact that that is absolutely only exists in a certain amount on the planet. It's plenty right now, but it's not something that is renewable. It's not something that will come back over time. And then our renewables are all of these sources of energy that we deem as inexhaustible. We anticipate that they will be around for a long time, and that they are will completely regenerate themselves over time. On this slide, you'll see the world energy production and electricity generation by source for our world energy and electricity generation. On the left, you'll see our energy production. Obviously, we know that our fossil fuels are our primary source of energy, and you'll see our oil, natural gas, and coal still primarily making up more than 3/4 of our energy production. You'll see bioenergy still there. We'll talk about that later in terms of even fuel wood being in that category, anything organic, living, more material in that category. About 10% of our whole energy picture. And then you'll see our renewables, including hydropower, just a small fraction of that world energy production. On the right, specifically targeting electricity, you'll see coal high up there at over 40%. We still here, even in the United States, use coal a great deal in our electricity generation. You'll see natural gas as well on there, another one of our fossil fuels. But then you'll also see some of those renewables, such as the bioenergy and the new renewables and the hydropower on there, making up almost 20% or more of the 20% of our electricity generation on the planet, and then nuclear over 10%. So you see it shifts a little bit, that we don't really use oil and electricity generation. Primarily we use our coal and our natural gas, and you'll see hydroelectric power showing itself a little bit higher in terms of electricity. So like I said on the previous slide, when we think about non-renewable resources, energy resources, we just say that they're resources that are not renewable in our lifetimes. So even though fossil fuels do form over time, it takes just way too much time for them to replenish themselves. Okay, they're not replenishing themselves fast enough to replace what we're extracting. Our extraction rate is way higher than being formed. So when we say not renewable in our lifetime, that's what we're talking about. Yes, in a sense they are renewable, but certainly not at the rate that we need to use them or choose to use them. All right, same idea with when we think about nuclear power. Again, uranium is not a renewable element. We are using it, and it is not replenishable on our planet. Okay, so I wanted to start our discussion here with fossil fuels. Okay, most electricity comes from the burning of fossil fuels. Okay, fossil fuels, like they sound, we know that fossils are long dead organisms compressed over millions of years. Okay, they are long dead organisms. So, of course, since they're organisms, they're fossils, they contain carbon. They are organic matter. They are compressed over millions of years, heat and pressure in the earth, and they turn into that solid coal, that liquid petroleum or oil, or that gas, which is our natural gas. We consider this to be stored potential energy sitting there, and then we extract it, we light it on fire, and it provides us a lot of power, okay, reliable power that we're good at using. Okay, about 2/3 of the fossil fuels are located in the Middle East. We know this, and about 83% of energy comes from fossil fuels. Okay, that's a number that I anticipate only will go down as we are slowly, very slowly, converting to renewable sources of energy. But about 83% of our energy here in the United States comes from the burning of fossil fuels. Okay, our table here, when we think about fossil fuel reserves on the planet, we see, as probably no surprise, some of our Middle Eastern countries there with our oil reserves, Saudi Arabia, we see Iran, Iraq, natural gas, Russia is up high, and Russia also has a lot of reserves of coal. You also see Qatar and Iran, no surprise in terms of, again, the Middle East, Saudi Arabia, Turkmenistan, and then coal, the U.S., we're way up high. China has a lot of coal that they use, Russia as well. So you'll see a lot of, again, our Middle Eastern countries, but also the U.S. and Russia and China up there in our coal reserves. Okay, those are the largest proven reserves of fossil fuels. Again, that doesn't mean it's what's being produced. That means that we know that they exist there. Okay, that doesn't mean they're being extracted and used. It just means that they're there. Okay, you'll notice that under our oil category, we see Venezuela and Canada, and they are asterisked, and I waited to mention them because their oil reserves occur as what we call oil sands. Okay, when you hear, for example, a tar sands oil, the Enbridge pipeline that exploded in the Kalamazoo River a couple of years ago up here in Michigan was tar sands oil, and this is a different type of oil that, again, it's called tar sands because it is a thicker, denser oil than our traditional crude, and it has to be refined differently, and our concerns about transport are different due to the fact that it is very dense and it doesn't float like traditional crude where we can kind of skim it off or burn it off. It sinks to the bottom of the water column, so that's really the challenges that the Enbridge pipeline disaster in the Kalamazoo River caused because we couldn't clean it. It couldn't be cleaned up. It was very difficult because it went to the bottom and flowed along the bottom of the river, and it was hard to identify where it was and get it out of there. Okay, so it's been a long couple of years working to clean that mess up north of us in Michigan. So let's break down our three different types of fossil fuels. I'm sure you're somewhat familiar with them. The first one I'm going to start with is coal. That is our solid fossil fuel. Then we'll talk about petroleum, our liquid, and then our natural gas. And lastly, before we move on to some of the problems with fossil fuels, we'll talk about other fossil fuels, some that are being extracted and used, and some that have potential but are not currently being used. All right, so the first one is our solid coal. Again, we're talking about a solid form of our dead organisms that have been compressed. Typically, we think of a lot of this being formed from our woody plant material. And again, the U.S. has the most coal resources, the most coal reserves. And we use a lot of coal here. Certainly up here in Michigan, we use a lot of coal, and we use nuclear power to produce our electricity. Those are our primary sources, and there's new restrictions that we will start probably to see some of that shifting away because of the concerns about how dirty coal is. And when we think about our three fossil fuels, our solid is the dirtiest. And as we kind of move down our list to oil and then to natural gas, they get cleaner. Okay, all fossil fuels do release a lot of carbon because, again, they are organic matter. So when you burn them, they release carbon gases. So they are dirty inherently. But when we kind of rank them in terms of how, which one's the least dirty to, the most dirty, coal certainly is the dirtiest, oil's in the middle. And then our natural gas is the cleanest burning of our three fossil fuels. Okay, so in terms of coal is our most abundant fossil fuel. We use it to generate electricity. Like I mentioned, Michigan does use a lot of coal up here. And we extract it through what we call strip mining or subsurface mining. Okay, strip mining, kind of stripping away the sides of mountains and extracting it. And subsurface mining, which means below the surface. So we know these deep coal mines that we see on the news, and unfortunately have been health concerns in the past, and obviously miners being trapped and such. So those are kind of the images that come to our mind when we think about subsurface mining. All right, there's four types of coal, and I don't believe this is in your textbook. So take a look at this. When we think about kind of the depth through the ground, okay, shallow, okay, closest to the surface, okay, closest to our feet, is P, and it's low in carbon, okay, because again, it's not compressed over a long period of time. It's going to have a low concentration of carbon. Okay, below that is what we define as lignite, and that's about 40% carbon. Okay, so it's been compressed somewhat, but still, in terms of composition, less than half percent carbon. Less than half of it contains carbon. And then when we think about the third layer down is what we call bituminous coal, and that has approximately 85% carbon. And then finally, the deepest of it we define as anthracite, and that has about 95% carbon. When we think about abundance, bituminous coal is the most abundant on the planet, and that is what we use. Okay, anthracite, we'd have to go even deeper to extract it from the earth, and we don't, okay, because it is just so deep and harder for us to extract and more expensive for us to extract. It certainly would be the most efficient to use if we could easily extract it because it has the most carbon content. Okay, so we can kind of get the most bang for our buck, so to speak, if we were to use anthracite. But bituminous still has a good carbon content at about 85%, so it is worth using because, again, it's abundant, and as much as it is pretty deep still, we do have some good extraction methods to get it. All right, when we think about in terms of production and use, okay, now remember what I said on our previous slide, that just because the reserves are there, that doesn't mean that all those reserves are being extracted
and refined and used. Okay, so when we think about production and use, actually those reserves that are extracted and produced, the United States and China produce and use the most coal. Okay, we are definitely I hate to say the worst offenders when we think about burning of coal, okay, and that dirtiness that's going up into the atmosphere. Okay, when we talk about climate change a little bit later in the semester, we'll kind of talk about the U.S. and China and how they're changing, hopefully changing policy in terms of that carbon pollution. Okay, we know that we have big meetings coming up in terms of climate change summit in Paris, so we'll see kind of how things play out in terms of the burning of fossil fuels, and certainly coal is a big part of that because U.S. and China have been in talks about what we can do as, again, the two countries that produce and use and burn the most coal. All right, so let's talk a little bit about our liquid fossil fuel, our petroleum or our oil, that syrupy liquid crude that often results from dead plankton. Okay, so we do we certainly do oil extraction over our terrestrial environment, but we also go into our water and extract petroleum from under the sea, the sea floor. So we know we have offshore drilling with our drilling rigs. Excuse me. We know about the Deepwater Horizon explosion. We know that with Shell trying to plan to drill in the Arctic and kind of pulling out because they don't believe the reserves are actually there. We know we've been doing offshore drilling for some time with obviously some concerns about control of those processes. Okay, but we think of that. When we think about an oil spill, we think about that syrupy liquid crude. We think about things like gasoline, jet fuels. Some of us heat our homes with oil heat. We have, we use petroleum in our asphalt. And, we do a lot of exploratory drilling around to see where we can get it. Later, we will talk about fracking and kind of our new way to extract petroleum and natural gas, kind of a newer technology that is being employed here in the United States to take advantage of our resources in our own country. Okay, when we think about the U.S. imports, we cover right around, I'd say 50% or so of our of our oil is imported. We anticipate that number will just drop because of our production here in the United States. Fracking, with all of its kind of challenges and concerns, has certainly increased the amount of oil that we are producing in the United States. Okay, so things are changing there, and it's changing pretty rapidly. Okay, only a few years ago it was much higher than that, but imports will continue to decline. And when we think about imports, don't only think about imports from the Middle East, but we bring in oil from Canada, etc. Okay, before we leave our discussion of oil, petroleum is not only what we put in our gas tanks and heat our homes with and use in our planes. Petroleum is in so many products. Okay, when we think about plastics, we use a lot of petroleum to produce plastics. Okay, so if you take a look there, everything from flooring, obviously plastic, CD cases, cleaning supplies, waste baskets, toothbrushes, plastic. You'll see all over the place. Tires, certainly we talked about roads. So there's just so many things that we use, not only oil to produce them, but they're also within the material. So it is, when we think about, okay, we just have to stop, using, gasoline in our vehicles, it's more than that. Okay, when we think about recycling, it is so important that we recycle all our plastics. That way we're not using more petroleum to produce them. Okay, so these things are all connected in one way or another, so we need to be conscious of the fact that, it's not just, when we think about, our cars are flying. Okay, it goes from, transportation of our food and trucks and trains and all those types of things. And just to move our coal around, we have to, drive trains. So that all takes energy to do that. So we have we have to use energy to move our energy around. And we have to use all of these components in our stuff. Okay, so the less stuff we use or purchase, the less will be produced. The more we can recycle, the less will be produced again initially. So really important, just another point I wanted to make there. On this slide, you'll see the United States oil imports, how about a third of our oil comes from Canada, and certainly there's talk about more of it coming from Canada later when we talk about fracking and the tar sands oil and the Keystone pipeline extension. All of those things could contribute to additional oil imports coming from Canada in their Alberta oil sands region. You'll also see some non-OPEC nations, Saudi Arabia and some of the other Middle Eastern countries like Iraq and Kuwait, etc. That's pretty much our oil import picture. Clearly we are in a period of increased production here in the United States because of fracking and other exploration of oil here. So we anticipate that the oil imports will continue to decrease overall, that we have to import from other countries. Okay, the last big fossil fuel that we use is natural gas. Okay, we think about natural gas being the cleanest burning of all of our fossil fuels. We use it to generate electricity. We use it to heat our homes. Some people have, gas stoves. We use it to cook. It is more efficient and therefore burns cleaner. It is less expensive than our other fossil fuels. And basically what happens is when we have petroleum or oil pools, for example, under the sea floor, okay, often above there'll be space where gas will accumulate. Okay, and we can tap into those natural gas areas and extract it up and out. Okay, when I mentioned fracking before, we frack for both oil and natural gas, so we'll talk about that in a little bit. When we think about it being cleaner, okay, we say it emits, natural gas emits about half as much CO2 or carbon dioxide as coal. Okay, so it is significantly cleaner, and that's like when you hear commercials about airports, for example, that are, being really efficient with energy. They're using natural gas at night, and they're using solar power in the daytime to power their airport, for example. They say, oh, it's clean, it's clean, it's clean. And it is cleaner, okay, because clearly they're using a renewable source of energy in the daytime, which is fantastic. And then at night they're using a non-renewable, but they're using the cleanest of the fossil fuels. So that's why they, they kind of throw that out there that it's clean energy. Okay, I would say it's cleaner energy. Okay, when we think about natural gas, we say Russia has the most natural gas. Okay, Russia has the most natural gas. And when we talk about that, we're talking about reserves, not production. There are other fossil fuels out there that I don't want to leave out, and your book certainly goes into these in greater detail if you can read about that in your textbook. The first one I have listed there is oil sands, and you'll see that picture I have below that. It says massive oil sands mine in Alberta. That's in Alberta, Canada. There is a tremendous amount of
what we call tar sands oil that we have begun to extract as an option for our energy needs. It is a different type of oil than our traditional crude that we've been extracting and using for transportation and home heating and all those typical oil resources are used for. But tar sands oil is a little bit different. It is a different consistency. It is a much denser oil, and unfortunately we have had some concerns related to tar sands oil contamination in pipelines. First of all, when we think about in Michigan, in the Kalamazoo River, we had a big oil spill that was this type of oil and was very difficult for cleanup to happen because it sank instead of floated. So our traditional methods of cleaning up oil, whether it's burning it off the surface or using bioremediation or dredging it or using booms to collect it, those methods just don't really work. So we have definite concerns about moving this oil around through our pipelines. Our refineries are not set up to deal with this type of oil, so we have retrofitted some of them to be able to refine this type of oil. And those refineries down in Texas, some of them can do that now. There has been a big proposal to put an extension on the Keystone pipeline that would pipe oil from all the way up in Canada all the way down to Texas. And I have something later on one of our slides related to the Keystone, and right now it's currently has not been approved to have the extension, but that may change with our new administration. So we'll have to wait and see kind of what happens with that. In addition to the oil sands that we have discovered are the oil shale. That's going to be rock. When you think about shale, you think about rock with organic matter in it. And we can change that into a liquid petroleum through strip or subsurface mining. It's just not a very efficient way to get a lot of oil, so it takes a lot of energy to get it for not a huge product. The last one I have on there is methane hydrate. That is really just a potential energy source. Methane hydrate is under the ocean floor, and we just have not figured out a way to safely extract it. The concern is that when you think about methane, you think about methane gas, and we're concerned that there'll be a massive gas release. It could become explosive. And that idea, we know it's there, but we haven't really made an effort to extract it because of the difficulties related to that and how expensive it would be to explore that option. This table shows us the difference in production and consumption of fossil fuels around the world. When we think about production, just keep in mind that we're talking about what's actually made, not what we know as a resource is available. We talk about that in terms of reserves. Production is what's actually extracted and is going to be used in some way or transported to be used. So you'll see obviously at the top, no real surprise there. We are near the top with China. China is producing a lot of coal. They have tremendous resources there, as do we. And China is also a huge consumer of coal, and we see the impact of that in terms of their air quality, their poor air quality in China that we'll talk about in our air pollution chapter. That's certainly a concern related to the use of fossil fuels, and coal being the dirtiest of our fossil fuels. Because they consume such high quantities of coal and burn it, they have concerns related to their air quality. We are, as much as we are such a small fraction of the population of China, we still use a lot of coal. We said certainly in electricity generation here in the United States, that is primarily what we use it for. You'll see other countries like India, We know India and China are the largest, have the largest populations on the planet. So it's interesting that we sit up there with them in terms of our consumption when we are such a small fraction of either of their population. Oil, you'll see there, no real surprise. We know that the Middle East, like Saudi Arabia, produces a lot of oil. We are up there as well now, and like I said, I expect us to continue increasing our production here in the United States. Russia's up there as well, and then obviously in consumption, you'll see us right on top there with about 20% of the world's consumption is us. Okay, we are way up there in terms of our oil use, our oil dependency. China is second to us, and again, they have so many more people than we do in their country. So it's interesting that we are the bigger consumers. And natural gas, again, we are as well. We are the largest producers and consumers of natural gas in the world. And again, we have been in a natural gas boom, leaving our prices much lower, and we kind of see ourselves there for some time as we move into the future. Overall, our fossil fuel picture, we do anticipate that we will decrease our use of fossil fuels over time, but it's going to take some time for us to kind of wean ourselves away from fossil fuels and using renewables and other options. You'll see there under natural gas, Russia is second to us, Iran third, and then you'll see some other countries, Qatar, China, Canada, and Japan there near the bottom.